Let's do some simplifying. We're going to start with prime factorization and we're going to work up to fractions. So, prime numbers. A prime number is a whole number greater than 1 whose only factors are 1 and itself. Positive integers other than 1, which are not prime, are called composite numbers. If they're not prime, they have 2 or more factors. So, for example, 4, the number 4, is not prime because it's 2 times 2. So, the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. We actually don't know how many prime numbers there are. Mathematicians have not found the largest prime number. They have a computer calculating and they still keep finding primes. So really kind of neat. So let's practice some prime factorization. We're going to take a natural number, which is a positive integer, and factor it completely until we're left with only prime factors. So let's just take a step back and think about what your natural numbers are or what your positive integers are. Remember when you were little and somebody would say, "How old are you?" And you're like, "I'm this many." And you would hold up 3 fingers, 1, 2, 3. Well, when you were little, you learned how to count using the counting numbers. So what we call our positive integers are really our counting numbers or our natural numbers, 1, 2, 3, 4, 5, 6. And then later when you were little, you learned about 0 and then negative numbers. So if you look at your counting numbers or your 1, 2, 3, 4, 5, your positive integers, and you also include 0, you get something called the whole numbers. Okay? And then if you include the negative integers, you get all of the integers. So a little background there. So let's practice prime factorization. We're going to take a natural number. So again, those are our counting numbers. And we're going to factor it all the way down to primes. So the first step is easy. You just pick any numbers you know that multiply together to give you 24. There's lots. So for example, you could pick, 2 and 12, 6 and 4, lots of things, 8 and 3. If you're not sure, you know that this ends in an even number, so you know for sure that 2 is a factor. So we do 2 times 12. Well, and this is a prime number, so I'm going to circle it. And let me factor 12 further, right? 12, you can think of lots of different ways maybe to write 12. If you're not sure, you can always use 2. But I know that 12 is 3 times 4. Well, 3 is a prime number as well. I'm going to keep breaking down the 4. So 4 can be factored down as 2 times 2. Those are the only choices. 2 is prime, so I'm going to circle it. Notice I'm circling my primes. So I look and I say, well, okay, 24 equals. I'm going to look at the values I've circled. 2 times 3 times 2 times 2. And those are dots, like for multiplication, not decimals. And probably you're not going to write it that way. You're probably going to put all the 2's together. 2 times 2 times 2 times 3. Okay. I want to show you something else. If we had factored it a little bit differently, 24, and we had started out with, for example, 6 and 4. I think it's what I said first. If you put 4 times 6, you break the 4 down. That's 2 times 2. And then you break down the 6. That's 2 times 3. Do you see we get exactly the same prime factors? So it doesn't really matter which factors you choose from the beginning. You may also see this written as 2 cubed times 3. Remember our exponent says if I have 1, 2, 3 of them, I can say so by writing a 3 as my power. And then 36, let's do that one. So I'm just going to move it over here, just have a little more room. 36, we can think of anything we want to that multiplies together to get 36. I don't know, maybe like 6 and 6. Again, you can choose anything. Notice there's lots of different ways to do this. You'll end up with different trees, but that's okay. So then we break 6 and 6 down further. 6 is 2 times 3. Hey, look, both of those are prime. And this 6 is 2 times 3. Both of those are prime. So we can see that 36 is 2 times 3 times 2 times 3. But again, you're probably not going to write them like that. You're probably going to put the 2's together and then the 3's together. So 36 is 2. Well, there's 2 of them. It's 2 squared. And 3, there's 2 of those, so 3 squared. And let's check it. What's 2 squared? Well, that's 4. What's 3 squared? 9. Is it 4 times 9 also 36? That's another way to check. Okay, let's look at factors of 132. So I don't know factors of 132 off the top of my head. So I know it ends in an even number, so I know 2 has to be a factor. So, and it's prime, okay? And then you go over here, if you can type this in a calculator if you want to, but 132 divided by 2. Well, then we say 2 times what gives me 13? Nothing, but what gives me close? 2 times 6 gives me 12, right? 2 times 6, and then 6 times 2 is 12, and then we subtract. Do you remember doing this? So 13 minus 12 is 1. Bring this 2 down, and 2 times what is 12? A 6. So we see 2 times 66 should be 132. Let's break 66 down into its prime factors. Well, 66, the numbers are doubled, right? Same digits are the same, so I know there's an 11 in there. So what about 6 times 11? Well, turns out 11's prime. Isn't that one of the ones on my list? Okay, so now let's factor the 6. 2 times 3. So it looks like 132 is 2 times 2 times 3 times 11. We could also write that as 2 squared times 3 times 11. Okay, so let's use this just to break down some fractions. So we have some fraction properties. If you have A times B times C, and you're dividing the whole thing by B and D, if you have the same factor on top and on bottom, it can cancel. Okay, so the B's would cancel. You're left with A times C all over D. So let's do a few. Simplify. Write without any negative exponents. Now, I know you can probably type this into a calculator, but let's practice this process so you can see what's happening. You can do it when things get more complicated. So let's break 10 down to its prime factorization. We didn't do that earlier. 10 is 2 times 5, right? Both of those are prime. So we're going to write 2 times 5. And 15, let's break that down to its prime factorization. Well, that's 3 times 5. Both of those are prime. So 3 times 5. So if you look here, you have a 5 on top and a 5 on bottom, right? This fraction property says you can cancel those if they're the same. So the 5's cancel. You're left with 2 over 3. Let's do some more. So what about 27 over 36? Well, we didn't factor 27, so 27 is like 9 times 3. 3 is prime, I'm going to circle it. And 9 is 3 times 3. So 27 looks like it's 3 times 3 times 3. And we did factor 36. We did that one up here. That was, let me scroll up just a bit, 2 times 2 times 3 times 3, right? From up here. Do they have anything in common? Is there any term that's in the top and in the bottom? Well, there's a 3 on top and a 3 on the bottom. Another 3 on top and a 3 on the bottom. So we look, what piece do we still have on top? We have a 3 on top. And on bottom, we have a 2 times 2. So this is going to be the same thing as 3/4. Okay, let's keep going. 20. We did not find the prime factorization of 20. So 20 is 4 times 5. 5 is prime. I can circle it, right? Then we factor 4. 4 is 2 times 2. So in the numerator, I can write 2 times 2 times 5. In the denominator, I'm going to write the factors of 132. I did those earlier, right? They're right here. So we get what? 2 times 2 times 3 times 11. Notice I have a 2 on top and there's a 2 on bottom. They cancel. I have a 2 on top and a 2 on bottom. They cancel. That's all they can cancel because nothing else is the same. So my numerator still has a 5 and the denominator has a 3 times 11. So we can write 5 over 33.